Hello and welcome to our SMARTColor part of our webinar session. My name is Fabian Wolf and I'm the product manager and leading developer of our tool SMARTColor. Joining me here is Jan Stotfang, CEO of our company, and he will help me answering questions maybe during or at the end of the presentation. So the webinar will be recorded and you will receive the certain download link for the video with an email after the webinar. There is a presentation part and a live demo part within this webinar, and at the end there is a Q&A session where we try to answer most of the questions or maybe all of your questions you have, and if we cannot, we will try to send you an email and answer it within there. So first, I want to give a short introduction about the usage of colors in technical areas. For example, you see images which are common for all of us, I think. Colors are used in for technical purposes, like for marking resistors, cables, tubes, and all of you who have already done finite element analysis or CFD analysis was happy about the colored images at the end, and you are used to that. And there are a variety of other different use cases for colors in the technical area. Specific in the CAD environment, colors are used for function-based display of assembly components and also for highlighting areas with a specific property or making faces with the same manufacturing strategy visible. So, and of course, the product presentation for marketing as well is a big use case for colors in CAD environment. But also here is lots of many other cases. So in a model-based world, how can colors help us improving our process? Colors may carry information like product and manufacturing information, PMI, as tolerances or surface finish properties, and can be reused in downstream processes like the manufacturing and the quality assurance. What's the traditional status of PMI transfer? Many of the companies are used to have a drawing-centric process where dimensions and GD&T annotations or surface finished symbols are used to communicate technical data. This is a stable and reliable process, but it does not give very much potential for downstream automatization and for improvement. So moving to a 3D approach and moving the 3D model as the single source of truth, more and more data and information is put from the drawing into the 3D model. And this opens a variety of possibilities. Formerly, we needed a fully dimensioned and annotated 2D drawing model because in downstream processes, the model was rebuilt for manufacturing purposes and for quality purposes. But today we have neutral interfaces or direct interfaces which can provide the geometry data for these systems, and they build the geometry automatically out of it. So today we only need specific information within a 3D model which helps us to ensure the design intent and the functionality of the component. So, but there's still often the 3D approach is a copy of the traditional 2D way. So first it's tried to migrate all of the 2D stuff into the 3D model. Also, but there's some disadvantages, like it's not very easy to apply GD&T and dimensional tolerances in a 3D model because there are other circumstances like the annotation plane, which you do not have in the 2D world. So, and also there are problems communicating semantic PMI through neutral interfaces like STEP, for example. So we recognized, and many of you, I'm sure, recognized that communicating GD&T annotations through STEP, you will have issues when re-importing it into Creo or exporting it just for the downstream consumption, that there are not quite that semantic as exported. So you will have information loss there. How should the PMI transfer be? We wish it to be easy and reliable for the downstream communication, and even via neutral interfaces like STEP and JT and so on. Also, within the company and abroad of the borders of the company. We want to speed up the process of transferring PMI, and a main goal is to reduce the amount of work for the designer, because when doing MBD, the downstream processes will profit from that more, or especially. So the design area, they will have more efforts to create the content, first of all, or just have the new process to apply. And therefore, it should be easy and effective to apply the PMI in the 3D. So, and also it's a great benefit for the PMI that they can be using an MBD approach processed automatically via machines downstream. So how can colors help us with that? What is a color? A color within the RGB red, green, blue color space is a combination of three values, the red, green, and blue part. So you see here, the labels of the colors are German, of course, but I think you can also understand that. And you see that the RGB color space provides more than 16 million possible combinations of color codes. So this color code can be used to assign specific amount of data or information to this within the consuming systems. So color codes are just attributes which can be semantically linked to a surface within a CAD model. And also this can be done for each surface individually. In comparison to the GD&T, color data can be transferred reliably using neutral interfaces like STEP, for example. Also, colors are human, readable, understandable, but of course there are limitations, because out of the over 16 million combinations of color codes, the human only can distinguish around a number of smaller than 100 colors. And also there are color blindness and other issues there. So, but the most powerful part of this, and this is why it's so valuable to use colors for an MBD process, is because they are machine readable by specific manufacturing programming systems or quality programming systems. For example, Hypermill. Hypermill has a feature recognition mechanism which allows to find holes and pockets within the geometry. And you can configure a technology database for Hypermill and combine it with a color table. So you can link a color code to a specific manufacturing macro. And this manufacturing macro maybe contains information like the cutting speed and the tool, for example. So when you load your colored model into such a programming system, the system recognizes all holes and pockets, for example, and together with the color information, it can derive automatically, and that's the great potential of that, can derive automatically all manufacturing steps, and the CAM programmer doesn't have to do it manually, and this saves a lot of time. So here's an example of a color table. This color table is provided by the company Meusburger. It's a huge standard part supplier in Austria for the mold base building area. And you see that on the left side, there's the color shown, RGB values for it. In the columns right to it, there's a tolerance values, position tolerance, and also surface quality. So what are the challenges when we plan to use colors for our process? Geometry selection is time-consuming manual task because user has to look at the geometry and pick one surface one after another. Also, he might forget such a surface, or we have to be aware that after coloring a model, the geometry is not at the end of its state. So the designer might continue his work on that geometry. So afterwards, he will have to adjust the coloring. In addition, it's also of advantage to have multiple color states or appearance states within the model. For example, one for the manufacturing purpose, one for the quality purpose. So it's not quite easy to have them simultaneously. And also there's a danger of misinterpretations by humans, so that is already mentioned. How can the software support with these issues? The software tries to help out on the time-consuming manual selection by an automated color application mechanism, which uses predefined rules. So by a single push of a button, rules can be executed, which are prepared by the administrator and just used by the user. Also, the software might provide enhanced selection mechanisms like loop selection, seeding boundary, and so on. Color codes should be categorized, and that helps us to get the correct colors which are relevant for my specific model, for my specific case. For example, depending on, do I have a mold plate or is it a sheet metal part or so on. And also it's very valuable to have analysis functions which give an overview which color codes do I already have in my model. So also pre-colored models can be used, and the software should also support of having multiple appearance states simultaneously. As I mentioned, that the human readability is a big problem because human only can distinguish a limited amount of different color codes and also the color blindness. So it would be of advantage if there is a legend symbol mechanism which semantically references the corresponding geometry surfaces. I will show that explicitly in the live demo, what I mean by that point. And also the software should give support for the downstream transfer. Okay, now I come to the demo part. So the demo part starts with my demo part. In the left area of my ribbon tab, SMARTColor, there's the administration area. So this can be used for setting up color codes, setting up rules, and assigning it to something we call context. Context, I will just show you within the user dialog. A context can be used to link a specific context to a combination state. So you see when I just change the context, a corresponding combination state will be activated. And that gives us a big advantage because when we now have an active combination state and we assign an appearance state, a Creo native appearance state to the combination state, then the colors applied will live inside that appearance state. And that is the requirement that you can access these colors also without SMARTColor software. And also within Creo View, for example. So first step is setting up the context, and one may be for quality, one for manufacturing, and also for other purposes. So on the first tab of this dialog, we see some predefined rules which are executed sequentially, and the user just can press the apply button to do that. So I will do it now. You see a little progress bar, and the appearance of the model has changed. So I will just move to the second context, apply a different set of rules. So I have to point out that for each combination state, I can then define a unique set of rules there. And for the third one as well. On the next tab, there is the possibility to choose a color category if there are multiple assigned. And you can also apply manually a specific color. So for example, there are two selection modes. One is just selecting a surface just after another without holding the string key. So if you have done a wrong selection, just reselect the surface and get the initial state. And there is also an enhanced selection mode where you can use enhanced selection mechanisms like loop surfaces, seed and boundary, and so on. The last tab within the dialog gives me an overview of all contained colors within my model. So the base color is applied to all colors initially, and then special geometry aspects are colored differently. So when clicking on the colors, I will see that all the corresponding geometry elements are highlighted within the model. And also I have it for my rule-based colored surfaces and for the manual applied colors. This is also distinguishable within that dropdown. So I can see which colors were applied manually and which were applied using the color code, the rules. Okay, so after I have applied my colors to the model, I can create color symbols. So that is that legend functionality I pointed out previously. So when the symbols are created, we see that they are semantically referencing the geometry when hovering over the symbols. The reason why there are no symbols for these two colors is that they are just not configured. So if I would choose another color to apply, I would get an additional symbol. Hopefully, I'm not aware of which one does actually have a color symbol applied. So creating the models again or pressing the update button in the ribbon will recreate the symbols. There's also no symbol attached to that, but it's not a problem. You can design your symbols as you want. So you can give them a frame. You can have variable text which are dynamically filled. For example, like this tolerance value, the RGB values, and the ID of the color code. If you look at this combination state, you will see they have a different appearance. And for example, here hovering over the color mask, you will see that all corresponding geometry is highlighted. When we now export this to Creo View, for example, then you will see that the highlighting mechanism, the semantic, is also working in Creo View. Let's wait for it to be finished. Okay, quickly opening it. And on the tab Viewables, we get one node here for every combined state. And we see we have also our color symbols. And now when selecting the geometry, we will see that the corresponding geometry aspects are also highlighted within the Creo view. Okay, so what I want to show you additionally, how can I set up my own rule to color automatically a certain geometry aspect? So here, for example, there is a standard bore, which is an ISO standard bore with a size 36, and we will create now a rule for that. The diameter is 32, and it is a whole feature which does own a set of geometry, a set of parameters like the screw size. I just will copy that value because it's more easier. What I do now is I go to the administration, and I have to point out here that the administration is only then accessible when a special environment variable is set. So when a regular user using, then this area is not visible. Just for the administrator, it's accessible. So in the left area, you can set up the contexts. In the right area, you can set up the objects, like defining color codes. Let's just enter it. Yeah. Here you can set the RGB values for a color code. You can define additional appearance settings like transparency, for example, if you unlock it here. And you can also add process information. This is information for the user like surface finish, position tolerance, offset tolerance. And you can assign a symbol just by giving the name and storing it in the correct location. And you can also configure a height for the symbol, activating a special group within a symbol, and you can fill dynamically variable texts. And there are prepared callouts you can use for, like, show me the surface finish value, the blue value, the description, the color ID, and so on. So what we want to do now is we want to create a new rule. And we start with the rule by entering a name, meaningful, hopefully, like thread bore 32, for example. Choose any nice color. We want to color it. So first of all, we have here now two nodes, our objective and a container. The objective is used to define what is to be colored. How is the geometry shaped I want to color? So this might be then, for example, I give a surface type at the beginning. So I want to have a cylinder. Then I want to add, so I want to have it closed. So there, it's not an arc, but it's a real cylinder, a hole. I add it shall have a thread, so the software checks the whole geometry for cosmetic kills, which are at the same position, coaxial, and also have a intersection with my surface. Now I check the diameter for that. I say it has to equal 32. And for the, I say it has to be stored. So this is the surface I want to color. And to shrink all the matches in the model, I can now add additional criterions, like it has to be owned by a feature that is of type, where is it? Whole. It's a whole feature, and I also want to shrink it that there is a certain parameter, like the screw size. And you can also use this parameter functionality when you, for example, assemble UDFs into your model and assign parameters to this UDF. So all geometry created by that UDF will be findable by the algorithm using that parameter, for example. And also, if you're interested in that topic, you can watch a video for EMX on that. It's very interesting and powerful functionality. So what I can add in addition would be that I can add a second objective. This might be a kilt or a surface. So I want to say that this one is not of type cylinder, but cone. So the tapered cone of the bore I want to include in my coloring mechanism. So then I think I'm done. All colors are summarized in color categories, and rules are summarized in rule sets. So when I color the context function, I see in the middle tree everything what is assigned to this context. So I see I have here the function rule set. This is here. So what I do now is, these are the rules belonging to that rule set function. I want to add additional one, and to be concrete, the one I just created, my thread bore. Saving, and now it's attached. So when I now apply the rules again, I will see that I have the thread bore also available for the rule application. And I can watch everything belonging to that rule in a read-only mode for the user. So when I apply the rules again, I see here that my bore is colored. I have it in the model overview. Clicking on it, I get my geometry highlighted. So this is basically how you go forward. You just start off and define your color codes. Then you will define your rules and organize all of this within the context. Be sure to prepare these combined states within your start parts, so you do not have to create it on the fly. So that would be the live demo part. And now I give the word to Jan, which might have some questions by the audience.
Okay, hello from my side. Thanks, Fabian, for this interesting presentation. I think this is a really interesting field of expertise that we're having here. And yes, we have a few questions coming in. And well, let me read out the first one. It's, I hope, a very simple one. And it's just, can SMARTColor be used in assembly mode?
Thanks, Jan, for that question. Yes, SMARTColor is also accessible in assembly mode as well as in part mode. In assembly mode, for example, you can define rules to color specific components which do own a specific parameter. So that would be one possible purpose for that.
Okay, so next one, what do we have? We have a question about the process. So if you have applied the rules once and you start working on the part again, how do you handle this modification in the part?
The software recognizes all geometry which is not there anymore, for example, by suppressing it. And of course, also new geometry is recognized. So the software stores for every surface the initial color appearance. And when you apply the rules again, and if you have, we have seen that there was a rule that colorizes all of the surfaces in a specific base color. So you can attach to that base color in downstream programs a general tolerance, for example, and you make sure, if you do so, that there is no surface which has no color code applied. So if you have well prepared your rule set, then the new geometry, maybe you create a new bore, will also be colored by the rule set. Just execute it, and your added bore will also be colored. And if it's another geometry which is not covered by the rules, then it will get colored by the base color. And if needed, if necessary, the user can manually add a different color to it.
Okay, I hope this answers your question. The last one I got so far, there's two coming in. So there's one about the legend symbols. Can you influence the size of the symbols and the appearance?
Yes, it's possible to just define via the Creo base functionality. You can set up your symbols and assign the symbols to the certain color code, and design it just as you want. And it's also possible to have variable text which are dynamically filled, so no need for hard-coded values inside its symbols. And also it's possible to activate a certain group within the symbol. So we're activating maybe an area which has a certain color. And there's a global configuration option which allows to define a scale for the symbols. You can define the size of the symbol individually for each color code, and also globally within the configuration, like create a symbols with a double size of the original size. So yes, it's definitely possible.
Okay, so I have one last. I hope one last question, probably coming in from Italy. What Creo version is supported by SMARTColor?
SMARTColor supports Creo 4, Creo 5, and Creo 6.
Well, that was easy. So I don't have any more questions so far. So if you will have questions afterwards, well, feel free to send us an email, contact us, ask for a demo license. If you like, so we are sending it out, including a demo configuration and a demo part, so you can play on your own if you like. You can subscribe to our YouTube channel, add our newsletters, and so far. Yeah, and well, I think this brings me to the end of the webinar. Thanks again to Fabian for the presentation, and thanks again for listening. Well, hopefully to hear from you tomorrow with our last webinar sessions. And yes, have a good day and have a good evening. Bye-bye. Thanks.